grade 8s. I've just been thinking about this problem, and it's been quite frustrating because I'm not really sure what to do. I have this balance, and it's kind of like a scale, kind of shows me equal weights. And right now, when this yellow indicator is pointing at this white line, it's showing me that both sides are equal. If I was to either take stuff off, then things kind of become equal when it's not pointing straight down. But anyways, my problem is this: I have these little canisters that kind of represent an X. They kind of represent this unknown number that I'm unsure about. And I know on my scale I have two of them, if I can just show you somehow. So I have two of these X's on the scale. You can see it's unbalanced now. And I also have one of these chips, which is worth 1. So kind of how this scale works, if they're sitting on the red cup, they're worth a positive 1. If they're sitting on the yellow cup, they're worth a negative 1. But right now, these are on the positive cup, and so they are all worth a +1. So I guess what I have on this side, under here, I have 2 X's. I have 2 X's there, and I also have a +3, so I have a 2X plus 3 on this side. And if I look at the other side and what I have in this red little cup, I got 1, 2, 3, 4, 5, 6, 7, 8. So I got 8 on this side. Did I count that right? Oh, whoops, I didn't see that one underneath there. I got +9. Need my eraser. Got +9 on this side. And so what we know here is that everything's balanced here. So there's my 2x plus 3. And since everything's balanced, I could put an equal sign in between these guys, because that's what this means. When everything's in balance, that's what they're equal. One side is the same as the next. But again, my goal with algebra is to try and solve for x. I want to get x all alone by itself and figure out what one of these x's is worth. And so, yeah, I'm kind of unsure about where to go next. Like if I was to take one of these green canisters off, is that gonna help me figure out what one of these x's is worth? I don't know. What else could I do? Because if I take this off, I still don't really know how much any of those are worth. But I think one of my goals is to keep things in balance. I want to be able to take things off without disrupting the balance. And in a way, I call that respecting the equal sign as well. So another idea I had was if I can use both of my hands, if I take 3 off each side at the same time, because that kind of makes sense, because if I have 3 here and 3 here, they should be of equal weight. So if I take them off at the same time, take them off the scale, I should be in great shape. And so things are still equally balanced there. It's equal, that's looking good. So basically what I've done is I've taken away, I've subtracted 3 from both sides. So now I'm left with, so I subtracted 3 here, I subtracted 3 here, so now I have 2x equals 6. And so now, hopefully I'm in a position to see what one of these x's is worth. So I guess one way I might do this is divide both sides in half. So if I have 2 x's, if I divide that by 2, I'll have 1x. If I divide 6 by 2, I'll have 3. And everything's in balance still. I think it's looking good. With 1x, this x being worth 3, this x was worth 3, and that seems to be a good way of doing it. One thing that I just want to keep in mind, and one really important thing that I had to do first was, if I think back to my original situation, when I had 2x plus 3 equals 9, if you didn't get anything from this last little section, maybe get this. The first thing we had to do was take off these white chips. We had to take off these white ones, which represented 1. So our first goal is to always get rid of these white chips. We always want to get rid of our whole numbers first. And that way we're at least left with these variables here. And even though there's more than one variable, at least we can begin dealing with that. So we always want to get rid of these first. Grade 8s, in our last topic we solved one-step equations, and so these ones are slightly trickier. There's going to be 2 steps to these today, and so if you think back to the example you just watched on the scale, there is one key thing that you're going to need to do, and I'll quickly remind you of that as we go through this. Let's look at our first intro example. Modeling with a balance scale. The city in Canada with the highest average wind speed is St. John's, Newfoundland. The city with the lowest average wind speed is Kelowna, British Columbia. The relationship between the wind speeds can be modeled using the equation S equals 4K plus 3, where S represents wind speed in St. John's and K represents the wind speed in Kelowna. If the average wind speed in St. John's is 23 kilometers an hour, what's the average wind speed in Kelowna? So we have this equation representing the relationship between these 2 wind speeds, and the question tells us that the wind speed in St. John's is 23. So what we have here is a scale, and it kind of models this equation. 23 equals 4K plus 3. Because we knew S was 23, so I just substituted 23 for S to get this equation. And that's what this scale models. And so again, if we think back to how we want to go about solving this, because again, our goal in algebra is to get that variable K all alone by itself. We want it to be a positive number, and we want it to be upstairs. It's already upstairs if I'm thinking about it in kind of a fraction way, so I don't have to worry about that, but I do want it to be positive. I do want it to be alone. Right now, it's not alone. There are 2 things happening to it. 3 is being added to it. Our variable is also being multiplied by 4. We don't want that. We want to get it all alone. So we're going to take some steps to do that right now. So if I'm thinking about it using a scale example, I think what I would want to do was I would want, again, like I did before, I want to use both hands. I want to pluck 3 ones off each side. Or in other words, I want to pluck or take 3 of these red squares off each side at the same time so the balance doesn't tip. If the balance tips, it's not equal anymore. We're dealing with equations. We want to keep things equal. We want to keep things the same. We want to keep the weight the same on each side. So if I take 3 off each side, that's going to leave me with 20 equals, whoops, equals 4k. So basically I subtracted 3 from both sides. That's what I did. So these have gone away, these have gone away. And so now hopefully I'm down to a, so that was the first step. The second step is I want to get this k all by itself. So this one I could solve by inspection. I could, what number times 4 would give me 20? It's 5. Or in other words, I can think of it as dividing both sides by 4. And k equals 5, which would be our wind speed in Kelowna. So, but this is kind of what, this is what we're dealing with today. There's 2 steps that you guys are going to have to do in these problems to isolate your variable. You're going to have to get rid of this number. I'm going to call it a constant because that's what it is. So we need to get rid of this first. So that was our first step, and then when there's a second step, to either multiply or divide. If you guys get into some questions where you are asked to model a situation, and I'm going to do one that's a little bit trickier that has a negative variable because you guys are going to encounter these, so we might as well have a look at one. So what I might start off with is I might start with a scale. I'm going to model this. There's my scale that these are going to sit on. So I need negative 3c. So my negative variables, if I think of them as algebra tiles, I can think of them as these rectangles. So each one of these represents a negative c. Then I have negative 5 on this side. 1, whoops, that's a positive. My negative tiles look like this. And then I have 10 on this side. So I'm going to fill these guys in. 1, 2, 3, 4, 5, 6. And I'm stacking them 3 high because my variables are stacked 3 high. So I just kind of organize my work that way, and if I do this, it's just easier to visualize what my variable is going to be in the end. So I got 6, 7, 8, 9, 10. So in our previous example, I was able to take 3 red squares off each side at the same time. I run into a bit of a problem when these are not the same, because in order to take things off and keep things equal, I need to take the same amount off both sides at the exact same time so that the scale does not tip. But in this situation, I got some negative ones right here and some positive ones. Negative ones and positive ones are not the same. So I cannot just simply take these 6 off and those 6 off. They are, a negative one and a positive one are very, very, very different. So, oh shoot, I have 6 here. I'm only supposed to have 5. I just realized. Okay, sorry. So I'm going to use another strategy that we used in integers a couple chapters ago. It's called making 0 pairs. So if I want this to be 0, if I want to get rid of this, another way I can do this is I can make these 0 pairs by adding plus 5. Initially it seems like that's going to make the problem worse. So I added 5 here, and then I'm going to add 5 here. So some of you are going to tell me, hey, this is now worse. I've actually added more stuff on the side of my variables. I'm in a worse off position than I was. But the great news is, if I have a negative 5 and a plus 5, I actually make a 0. So this is now worth 0. So it's almost like, because it is like, we can take all of this off, and it will not make the scales tip if it's 0. It's like if all of this is worth 0, in a way I can think of it as nothing. If I take nothing off, there ain't going to be no scales tipping. And so Now I'm just down to negative c, so I'm going to actually erase all these guys, since I can take them away. I have negative c equals 15. And maybe one thing I could say, I can now see that I have 3 variables here and 3 rows of 5 here. So what I've come to the conclusion that a negative c equals plus 5. But I'm still not done yet because my variable is not positive. Remember, in the end, my variable must always be a positive amount. And so to do this, we multiply both sides by negative 1. And if we think of it this way, a negative 1 times c is c, and negative 1 times positive 5 is negative 5. So in the end, this is what I want. I want to get to this point where c equals negative 5. Another way of thinking about it, well, the best way of thinking about it is multiplying by negative 1. But really what we're doing is we're just changing the sides on both sides. So that just is going to become a positive, and that is going to become a negative. And we're only doing that if we end up with a negative variable. If this side's negative, it was like, if I ended up with x equals negative 15, that's great. Don't flip anything. But if you end up with negative x equals something, then you gotta change both sides. The first thing you always want to do is you always want to add and subtract first on the same side as your variable. You want to get rid of that constant term, that number by itself with no variable attached. Just like at the first part of the video, I took 3 of those white chips off both sides. Those were numbers. Those were like my constant term. In the wind example in St. John's and Kelowna, I took the 3 red squares off both sides of the scale at the same time. I want to add or subtract first. I want to take off or add the 0 pairs like we saw first. So this is always step 1. Step 2, then you can simplify by multiplying and dividing. Okay, let's look at a few more examples. I have 4 plus 26g equals negative 48. So there's 2 things that I could do because I have 2 things happening to g. It's being multiplied by 26. 4 is also being added to that amount. But if I think back to my previous slide, the first thing I want to do is I either want to add or subtract something. Something on the same side as my variable. I can't subtract a 26 because that's not the opposite operation to what's happening here, but I can subtract this 4. So this is what I want to do first. And I want to do it to both sides because it's an equation. I want to keep things equal. And yeah, your first step always involves getting rid of that constant term on the same side as your variable. So 4 minus 4 is 0. I'm not even going to write that down. I'm just going to write down a 26g equals negative 52. My second step is now I can simplify by multiplying or dividing. So in this case, I have 26 times g. The opposite to times or multiplication is dividing. So I'm going to divide both sides by 26 to keep things in balance. 26 divided by 26 is 1. 1 times g is just g. That's awesome. I've gotten g all alone by itself. Negative divided by a positive is a negative. 52 divided by 26 is 2. G equals negative 2. Okay, if the question says verify, you have to do it. And if the question doesn't say verify, you don't have to do it, but I still recommend doing it because you can make sure that your answer is always correct. So when I verify, here's what I'm doing. I'm taking my original equation, 4 plus 26g equals negative 48. I'm taking the value that I got for g, putting it into my original equation. So that's going to look like a 4 plus 26 times negative 2. So I put the variable into the original equation. Maybe I'll write that down. To verify, put variable into, put the variable actually doesn't help. I want to put the number that I got for the variable. How about, let's call it variable value into the original equation. That is my first step. Then I just want to check if the left-hand side equals the right-hand side. So I want to check if the left-hand side equals the right-hand side. That's what I want to do. I want to see if this left-hand side is actually equal to this right-hand side. So I'm going to go 26 times negative 2, following the order of operations, is negative 52. 4, so I'm down to a 4 plus negative 52. 4 plus negative 52 is negative 48. And if the left-hand side equals the right-hand side, it's verified, it's done. We know that it tells us that this solution is correct. Let's look at the next one. 3x plus 7 equals 19. So again, the first thing I want to do is I want to get rid of this constant, the number by itself on the same side as my variable. So I'm going to subtract by 7 on both sides. Subtract by 7. Seven minus 7 is just going to give me a 0, so I just cross them off. It's like they cancel, but really I'm canceling it because it just makes a 0. And I'm left with negative 3x equals 19. Nope. 19 minus 7 is actually 12. Oopsie. Okay, now I want to simplify either by multiplying or dividing. So I'm going to simplify by dividing by negative 3. And because that's going to leave me, a negative 3 divided by negative 3 is a plus 1. I'm left with x equals negative 4. Now I want to verify. Negative 3x plus 7 equals 19. So I'm going to put a negative 3. I'm going to substitute this negative 4 in for x. Equals negative 4 plus 7 equals 19. Negative 3 times negative 4 is 12. 12 plus 7 is 19. The left-hand side equals the right-hand side. I am now done. So hopefully you learned a couple things today. Number one, that we're dealing with these two-step equations, that the first step is always to add or subtract first the number on the same side as your variable. That's going to be your step one. Your step two is then either to solve by multiplication or division, or by solve I mean simplify and get x by itself. We're still doing the same goal. We're still trying to get x by itself. We just have another extra step that we need to do today. So hopefully that makes sense. Take care. Goodbye.